So here's our system connected to the AFM. Here's our stepper motors, and here's our detector. And here's the Arduino, the two stepper drivers. There's a button here, and try to line that laser onto the cantilever, which is right here. So this assembly here holds the cantilever, and we're trying to align it onto there.
So here is how the algorithm works. First, we bottom out the both X and Y screw all the way to here, and then we offset it to somewhere near the chip. Then we start scanning. Once it's scanning, it will first meet no matter which edge. Once it meets the edge of the chip, we start measure the width. If the width is too wide, we go back and do the offset again. Then we start scanning again. If it's still too wide, we do the offset again. Finally, we will find the proper width, which is the cantilever, but not the chip. Then, after we measure the width, we go back half the steps that we measured and stop here. And then we go all the way up and find the top edge, and after we find the top edge, we stop here and offset it to somewhere around here, which will be the place we want it to be. So we're done with alignment.
So as each step is occurring, we have an output to the console here. So right now we need to press the button here, and it'll start turning these two motors to align the laser to a known spot. So here we can see it's bottoming out X. And now we're bottoming out the Y motor. So we're turning these motors all the way until they stop. And then we move the two motors to a known offset. And once that's done, we have a prompt to press the button to start scanning for the cantilever. And as we're scanning, we get values out of the system. So if you see, there's a little laser spot down there, and that's with the laser aligned onto the cantilever. And on the system, this is what it looks like. We have the amount of light detected by the photodetectors within the actual AFM. So this whole system is not interfaced with us, we're just interfacing with aligning the laser.
Okay, so here we have our circuit setup, and from the oscilloscope we actually can discern the oscillating behaviors. So right here we have our laser setup. It's set up in order to reflect off our piezo that's going to be oscillating. So here, let me flip on the switch, okay, and so we're running it at 100 hertz. We're doing a sweep all the way to 10,000 hertz, and then we also run it at 3,000. And then 5,120, which is actually the resonance of the piezo, and then 7,000.